For 30 years, Detroit's Tier 1 supply chain told the world that the inverter was a commodity, that 94% efficiency was the unavoidable cost of silicon physics, and any automaker who wanted to compete simply bought the same Infineon IGBT modules as everyone else. Physics doesn't negotiate. The Cadillac LYRIQ just proved every word of it wrong. Inside BYD's FinDreams semiconductor division in Shenzhen, engineers have achieved 99.7% peak inverter efficiency, not by sourcing a better component, but by building the component themselves, from silicon carbide powder to finished chip to power module to vehicle. At 150 kilowatts of continuous output, the Cadillac LYRIQ's inverter generates 9 kilowatts of waste heat. BYD's equivalent generates 3.7. That 5.3 kilowatt gap doesn't disappear. It bleeds out of your range budget on every highway mile, every mountain pass, every towing run across Colorado. This is not just an efficiency story. This is a chip story, a supply chain story, a $35 billion Ultium story. The outsourcing doctrine was not born from laziness. It was born from logic. In 1997, Toyota launched the Prius with a Denso-manufactured IGBT module. It worked. Every automaker watching drew the same conclusion: power electronics are infrastructure, not differentiation. You buy them the way you buy steel. GM carried that doctrine into the Bolt, and ultimately, the Ultium platform. For 2 decades, the premise held, because when range anxiety was the industry's defining problem, a 6% inverter loss was invisible behind a 60-mile range headline. In 2018, Tesla deployed silicon carbide MOSFETs in the Model 3. Detroit noticed. Detroit called it a niche premium decision. Detroit kept buying Infineon modules. What Detroit did not see was the factory being built in Shenzhen not to use silicon carbide, but to manufacture it. Every inverter converts DC battery power into the AC current that drives the motor. In that conversion, energy is lost not through negligence, but through physics. Silicon IGBT transistors switch on and off between 10,000 and 20,000 times per second. Each transition bleeds energy as heat. At 150 kilowatts of continuous output, the Cadillac LYRIQ's Ultium inverter generates approximately 9 kilowatts of waste heat that must be actively cooled, adding weight, adding complexity, and drawing from the same battery pack that is supposed to move the car forward. Silicon carbide operates differently. Its band gap, the energy threshold electrons must cross to conduct, is 3.26 electron volts versus 1.12 for conventional silicon. That wider gap allows SiC transistors to switch at 50,000 cycles per second, while generating a fraction of the heat. BYD's FinDreams inverter dissipates 3.7 kilowatts at the same 150 kilowatt output. The gap is not marginal. On a sustained 45-minute mountain tow through Colorado, the LYRIQ's inverter generates 24,300 watt-hours of waste heat. BYD's generates 9,990. The difference in cooling mass required to manage that heat adds approximately 18 kilograms to the LYRIQ's powertrain weight that exists solely to compensate for an architecture decision made in 2018. GM does not make its own inverter chips. The Ultium platform sources silicon IGBT power modules from Infineon Technologies in Munich and ST Microelectronics in Geneva. Both are European companies. Neither is subject to US trade policy leverage. Both set their own pricing, their own allocation schedules, and their own technology roadmaps that GM must follow, not lead. This is not a theoretical risk. In 2021 and 2022, silicon chip shortages forced GM to ship vehicles without fuel management modules and park finished trucks in lots waiting for components. The Cadillac LYRIQ itself saw production pause twice in 2023 and 2024, partly due to Ultium power electronics integration issues tied to external supply dependencies. The one credible domestic alternative, Was Wolfspeed the only major US-based silicon carbide wafer manufacturer and a recipient of $1.3 billion in CHIPS Act federal funding? Wolfspeed filed for Chapter 11 bankruptcy in October 2024. America's only serious SiC wafer producer collapsed while receiving government money intended to secure exactly the supply chain. BYD, meanwhile, now controls its own SiC wafer fab chip, design module assembly, and vehicle integration under a single corporate roof. When an Infineon price increase lands on GM's procurement desk, BYD does not receive the same email. The Cadillac LYRIQ carries a 94 kilowatt-hour battery pack. A 5.7 percentage point inverter efficiency deficit means that 5.36 kilowatt-hours of energy are lost to heat on every full discharge cycle before the motor turns a single revolution. Over 50,000 miles of US highway driving that inverter inefficiency consumes approximately 2,678 kilowatt hours. At the national average electricity rate of 14 cents per kilowatt hour, that is $375 in electricity, that heated the inverter instead of moving the car. But the more consequential cost is structural. GM engineers had to size the LYRIQ's battery pack to deliver 307 miles of EPA range despite the inverter loss, meaning the pack carries additional cells, additional weight, and additional costs to compensate for a thermal penalty that BYD's architecture eliminates entirely. At peak towing loads of 200 kilowatts, the gap widens further. The LYRIQ's IGBT inverter dissipates approximately 12 kilowatts under sustained tow, the equivalent of running 3 residential space heaters inside your powertrain while climbing a mountain. BYD's SiC-equivalent dissipates under 600 watts in the same condition. For a truck buyer in Colorado or Montana who chose the LYRIQ AWD Sport for its towing spec, this is not an engineering footnote. It is the reason the range estimate on the brochure does not survive contact with a trailer. Tesla's 2018 SiC decision was significant, but Tesla still buys its silicon carbide chips from STMicroelectronics. The supply chain dependency moved from silicon IGBT to SiC MOSFET, but the structural relationship remained an external semiconductor company, controls the cost curve, the allocation, and the next generation roadmap. BYD made a different decision. FinDreams Semiconductor, established as a BYD subsidiary, produces silicon carbide from raw material through finished power module inside a single integrated operation. The cost target is approximately $15 per inverter module against an open market price of $45 to $60 for equivalent size C components in 2024. That $30 to $45 per unit cost advantage compounds across 1.76 million SiC-equipped vehicles shipped in 2024 alone. It also means BYD's inverter efficiency improves on BYD's timeline, not Infineon's or STMicro's. The analogy is precise. BYD's relationship to power electronics is what Apple's relationship to processors became after the M1 chip in 2020. Once you own the silicon, you own the performance curve, the cost curve, and the competitive moat. GM is still waiting for Qualcomm to call back. The Cadillac LYRIQ is not a bad car. That is precisely the problem. Its 307-mile EPA range is competitive. Its interior is genuinely luxurious. Its Super Cruise driver assistance system works. At $58,590 base, it represents GM's most credible answer to the question of whether American automakers can build a desirable electric vehicle. Hundreds of thousands of Americans have chosen it. The engineering team in Warren, Michigan deserves credit for what they built. What they built, however, is a luxury EV whose power electronics architecture was already one generation behind when it launched. The Model 3 proved SiC superior in 2018. The LYRIQ launched in 2021 on silicon IGBT. It is now 2026, and the Ultium platform has no confirmed SiC transition on its production roadmap. GM has committed $35 billion to an inverter architecture that a competitor abandoned 8 years ago. The range consequence is direct. Engineering models projecting a SiC-equivalent inverter into the LYRIQ's existing 94 kilowatt-hour pack with no other changes estimate a real-world highway range improvement of 14 to 20 miles. That is not a software update away. It requires a new power module, new thermal management hardware, new gate driver circuitry, and new inverter housing on a platform already in production at scale. That is a multi-year redesign, not a product cycle refresh. The towing consequence is more immediate. The LYRIQ AWD Sport is rated for 3,500 pounds of towing capacity. Under sustained trailer load on a 6% highway grade, the kind of grade that characterizes I-70 through the Rockies. The LYRIQ's IGBT inverter runs at near peak thermal load for extended periods, compressing the thermal headroom that protects the power module from damage. BYD's SiC inverter in the same scenario operates at less than a third of its thermal ceiling. The engineering margin is not comparable. Ford's position is structurally identical. The Mustang Mach-E uses a Bosch-sourced silicon inverter operating at approximately 91% peak efficiency, lower than GM Ultium, and 8.7 percentage points below BYD FinDreams. Stellantis's STLA large platform. The architecture underpinning any future electrified Ram performance truck deploys a Magna e-drive module built on the same silicon IGBT foundation. Every major American EV platform currently in production shares the same inverter liability. None of them manufacture their own chips. In October 2024, Wolfspeed, the only major American silicon carbide wafer manufacturer, filed for Chapter 11 bankruptcy. It had received $1.3 billion in federal CHIPS Act funding. It had a customer list that included Volkswagen, Renault, and several U.S. defense contractors. It collapsed anyway under the weight of a capital expenditure program it could not sustain against falling SiC prices driven by Chinese production scale. The single most important domestic piece of America's power semiconductor supply chain was eliminated not by a tariff war, not by export controls, but by a cost curve that China's vertical integration strategy had already won. The CHIPS Act itself tells the same story in reverse. Congress allocated $52 billion to rebuild American semiconductor manufacturing. The investment targeted advanced logic nodes, the chips inside smartphones, data centers, and AI accelerators. Not $1 was specifically allocated to silicon carbide power semiconductors for automotive applications. Washington funded the wrong architecture at scale at the exact moment the automotive industry's most critical supply chain vulnerability was becoming irreversible. The Tier 1 supplier exposure compounds the problem. BorgWarner, Delphi Technologies, and Dana Incorporated collectively generate approximately $45 billion in annual revenue from powertrain electronics supplied to American OEMs. BYD's $15 per module. Internal cost target does not threaten those companies directly. BYD does not sell into their customer base, but it sets a global cost benchmark that Infineon and STMicro will be forced to chase, compressing the margins that sustain BorgWarner's inverter business and Delphi's power module programs. The jobs at risk are not assembly line jobs. They are engineering jobs, procurement jobs, and manufacturing jobs in supplier facilities across Ohio, Michigan, and Indiana that no tariff wall protects. What happens next depends not on tariffs, but on whether American engineering culture can move faster than it has in the last 30 years of outsourcing. The Cadillac LYRIQ is a beautiful car built on a decade-old inverter architecture. That is not an opinion. It is a specification sheet. GM did not make a reckless decision. It made a rational one rational by the standards of an industry that had spent 30 years treating power electronics as a procurement category, rather than a strategic asset. The Ultium platform represents genuine engineering ambition. The LYRIQ is a genuinely competitive vehicle, but ambition built on someone else's silicon has a ceiling, and that ceiling is now visible. BYD did not win this round by building a better car. It won by building the component inside the car and then building the factory that makes the component in the supply chain that feeds the factory. That sequence of vertical decisions compounded over a decade is what 99.7% efficiency actually represents. Not a spec, a strategy. Wolf speed is gone. The CHIPS Act funded the wrong chips. Infineon sets GM's inverter roadmap from Munich, and the only American automaker currently deploying silicon carbide at scale is Tesla, still buying its wafers from ST Microelectronics in Geneva. The question is not whether silicon carbide is the future of automotive power electronics. That was settled in 2018. The question is whether any American company will still be manufacturing its own inverter technology in 2030, or whether the most critical component in every electric vehicle will be sourced from a continent that has already decided to treat automotive semiconductors as a strategic weapon. Detroit has survived oil crises, bailouts, and recessions. But this is the first time Detroit has entered a technology war where the enemy doesn't just build a better car, they build the chip inside it.